So we've talked about what data science is. We talked about who a data scientist is. Now we want to talk about, so what do they do? First of all, I'll just go through, they manage data. I'll just go through this they do data transformation. I'll explain them shortly. Then you talk about data visualization. They build models, they evaluate models, and they monitor models. So now let's go back on data management. Data management is about collecting data. Most times data comes from different sources. So it depends on the industry you're working on. For example, if you're working with a social media industry, like in the social media space, for example, you can get data coming from Twitter, Facebook, Instagram, and most of the times different data sources comes in different formats. So you should know how to collect the data and store it securely in a particular location. So if you want to start doing data management, you also want to look at things like SQL and handling structured database and unstructured databases. So you have to collect data, store it in a database. Then you can now start looking at data transformation. In most cases, where you extract, like I mentioned, that data comes from different sources, and sometimes, and most times, the different sources have different formats and different nomenclatures. So you want to know, okay, if I extract this data, you want to also transform it so that you have like a uniform structure for your data generally. So that's where data transformation comes in. They call it the ETL process. So you have the extract, transform, and load. So you extract the data from the different sources, you transform the data so that you have a uniform look of the data. Then you load the data. In some industries, in some companies, they use extract, load, and transform. That's ELT, but the general one is extract, transform, load. Then you save it in the central, the data you've transformed, you load it in a central repository. In most cases, it's called warehouse. So you have data lakes, database, and you have data warehouse. Most times, data lakes is where everything is just dumped. Then your data warehouse is where you've cleaned up the data that your analyst can pick and start using. From data transformation and integration, most data integration and transformation, then we'll start looking at visualization. So if I've collected the data, I want to see what I have in there. So you kind of represent your data graphically, and there are different ways to visualize your data. And let me just show you some examples of visualization. There are lots of visualization out there that you can use. So depending on the question you want to answer or the insights you want to see. So for example, you want to see pie chart. Pie chart are used to show proportion. So for example, I want to maybe if I want to take a database of people attending this call. We have males and females. So if I want to represent what's the proportion of male to female I have, a good way to look at that would be a pie chart. It just shows you that data proportion of different categories within your data. You also have bar charts. You want to see maybe the count of different. Let's say, for example, we have different schools present in this call today. I can say, okay, if I get the data of the people names and their school they represent, I can say, okay, let me do a bar chart of the number of the schools represented. The higher bars represent people that have the school with the highest population. So that's how you then you also do column chart. Column chart is also like a bar chart depending on what you want to see. Then you have a line chart. Line charts are used to show trends. I want to see, okay, for example, if you are working with let's say an oil and gas field, for example, and you have this particular well, when you say, okay, how much has this well produced? You can say, okay, daily production of this well. So, okay, maybe on the first day the well is opened, you see the chart. You can now say, okay, the trend. So, okay, maybe with that you're able to spot. For example, you have a lot of wells. If you do a line chart of the different wells, you can say, okay, maybe this well is performing better than other wells. You can say, okay, maybe within a particular time, the production for this well dropped. You can now start asking yourself, why am I seeing a reduction in the production of a particular well, a particular field? These are where some questions you can start asking, okay, if this was a well shut in, do I need other enhanced recovery method to increase production from this well? So those are some of the things you're able to analyze trends over time. Then you also have area charts. You can also use it to show trends, but when you're plotting different things, you can see the area distribution of the plot. You also have a donut plot that shows you, it's like a pie chart as well, but it's just in form of a donut shape. Then you have tree maps that just shows you subdivision of different things. You have bubble chart. That could also be a scatter plot. A scatter plot where you are plotting two x against y. For example, I want to see the trend of between two verses. You are comparing two variables to say how do they differ. So I want to see, are they correlatable, are they not correlatable. Then the bubble chart is more like a scatter plot, but maybe you're introducing a third dimension where you say, okay, for example, if I want to plot x against y, let's say I want to plot neutron versus density. At the same time, I want to know if they have high gamma ray or not. So the bubble size could be the gamma rays, where you have big bubbles. Okay, big bubble represents higher gamma ray, and smaller bubbles represent smaller gamma ray radius. So that's how you can use these different plots. I don't want to go deep into explaining everything, but just wanted to show you some kind of key charts you can come across and what they are used for, so you can always go back to read about them. So okay, if I want to start doing analysis, you want to say, okay, what do I want to, what plots, because doing data analysis, data science is not just about creating plots as I want. It's about what question do I want, what insight do I want to communicate. And there are different plots that shows different, like I explained for pie chart. If I want to show distribution, or I want to show proportion, it's better to use a pie chart that would communicate my analysis better. So it all depends on your understanding of the data, your understanding of data analysis processes, to know what kind of chart will communicate my idea better. Then we'll also go down to, so after data visualization, then you can now start looking at, okay, building your model. In some cases, data visualization, data transformation might go hand in hand. Maybe after visualizing your data, you feel like, okay, I need to transform certain things, but that's when you go into model building itself. I will explain that later. Then we'll now talk about model building. So it's about model building, it's about training data to analyze. In some of these analysis, you do by just plotting graphs. So in some cases, you need to train machine learning models to pick out, there's some trends, or there are some patterns that you may not really see, but the machine can actually see. There are lots of machine learning algorithms that you can now start training to identify that patterns, and based on the patterns it has seen, it cannot make prediction. So for example, you have supervised machine learning and unsupervised machine learning. For supervised machine learning, you have a label. For example, I use this example very well. So if, let's say, it's like training a model is about teaching let's say it's like teaching the child what to do. So you can bring like maybe you have a dog and a cat. You tell the child, this is a dog, and you tell the child, this is a cat. So that when the child comes and sees a cat tomorrow, you can say, okay, oh, this is a cat. You've shown me that this is a cat before. I can now say this is a cat. You can say, oh, okay, you've told me that this is an elephant. So whenever I see something that has a big ear with a long nose, I should be able to say it's an elephant. So that is similar to model building, training models. Okay, yeah, you provide what they need to learn about. Then, so that when they see it again, they're able to say, okay, this must be this must be this. Okay, then that's for supervised. But unsupervised, you don't tell the child, like let's say your child, you don't tell the child what a cat is, or what a lion is, or what an elephant is. It's about, okay, bringing different animals, and based on different features, you say, okay, group this animal into different categories. So the child, if in this case, let's just use child for example, the child can say, oh, anything that has whiskers, let me group them in one category. Maybe anything that has a tail, I'll group them in. So that's supervised. So you don't know what the thing is, but it's based on similarities between the data points. Let me put them in different bins. So, and some example of unsupervised is clustering algorithm. Then for supervised, I mentioned supervised earlier, you could have a classification problem or a regression problem. Classification is trying to say, is it like a cat or a dog? But in other cases, you want to predict a number. I want to predict the price of a house. I want to predict the production of a particular well. Those are continuous variables. So in that case, you want to go for a regression analysis rather than a classification. Classification is, would it be cold today or will it be hot tomorrow? But regression will be, what will be the temperature tomorrow? What would be the temperature today? So using that, so that's how you differentiate between classification and regression. After building your models, at least you have built your model to identify different things, then you want to then evaluate your model. So you want to evaluate your model. How good is your model? Is it doing well? So you want to get good predictions. If you, for example, if you have a model that out of 10 items, it's able to predict only one correctly, that means that model is not good enough. So you want to go for something with high percentage probability or prediction probability, right? Then once you train your model, you've evaluated your model, you deploy your model, but you also track the model. So when you deploy your model into production, You want to see, yes, for example, I train a model that can tell me if this is a little, if like different lithology, if it's a sand or shell. I want to also monitor the model. So when I deploy the model where maybe to an interface where somebody can just bring in their well logs, and by clicking a button, it will say, oh, this is shell, this is sand. You also want to monitor the model. Is the model really doing what I want it to do? Is it mispredicting? So for example, you bring something and it says sand and it's supposed to be shell. You say, okay, is the model really doing what it wants to do? So do I need to upgrade the model? Do I need to retrain the model? Do I need to get more data? So those are some questions you start asking. So that's in general what a data scientist do.